A ball is thrown upwards from the ground with an initial speed of 25 meters per second. That should be the initial speed of the ball. At the same instant, at the same time, something else will happen. A ball is dropped from rest. So the initial speed of the ball, of the second ball, this is the first one, and this is the second one, will also, but now one of them is being thrown up from the ground and the other one will be dropped down from a building 15 meters high. After how long will the balls be at the same height? 1 and 2. Remember, one is being thrown up and at the same time ball 2 is dropped down. The question is, after how long? He's asking about the time. They will be at the same height, ignoring a resistance. When you see ignoring a resistance, it means that A equal G. Right? It's exactly, Shabab, exactly, to be honest with you, it's A equal minus G. I'll talk about this part, inshallah, in chapter 3. Is it really G if we have a free falling object, if there is no resistance? Shall I put it A equal G or negative G? In the problem, yeah. Sometimes you will find me just put it as G, and other times I will put it as negative G. هي الحقيقة يا شباب it's negative G, okay? But I will show you exactly when we can put it as G or negative G. Just to follow me. Forget about this now. Let us just imagine how the problem works. I will make a sketch. Probably, Shabab, when you make this sketch, if you draw the sketch, that makes things much easier for you. You can imagine exactly the problem. This is the ground. We have a ball 1, that will be thrown up with an initial speed of 25 meters. So V initial is 25 meters per second, and it will be thrown up. At the same time, another ball will be fall down from a building. This is 2 that falls down with an initial speed 0, because he said that dropped from rest. So even if he didn't need actually to say from rest, because the word when you say that dropped means that the initial speed equal 0. So after how? So this is going up and this is going down. Of course, they will meet at some point here. Let us say, for example, they will meet at that height. Remember, this height is 15 meters. The building has 15 meters long, 15 meters high. Let us say that this height is h. Anything. Let us call it h, d, x, whatever you want to say. This is h. So that distance now seems to be 15 minus h. It should be 15 minus h. That makes things much easier. The question is about the time. How long they will take to reach this height, at which, and this height, because this is the height at which they will meet each other. So what we're gonna use, Shabab, what equations we're gonna use to solve this problem? I will need to find 2 equations. One for the first ball that moves up and one for the second one that moves down. So let us say we can use this one, D equal VIT plus half a t squared. This is the equation that I will use in both cases, for ball 1 and ball 2. Let us apply it for ball 1 in the first case. So D is h. The distance will be traveled here and it will take a time t. So D will be h. VI of ball 1 is 25, so it should be 25 times t plus half and a. Yes, the acceleration of gravity, Shabab, as long as, inshallah, we're going to discuss that in more details in Newton's laws. This is called, when the air resistance is 0, this is called the free falling object. Shabab, free falling object It doesn't only mean that an object that falls down. لا. Even the object is moving upward, as long as there is no resistance, the acceleration will be g. But the acceleration normally is negative g, because the acceleration is always referring to the gravity or to the ground, and this direction is negative, so g is always negative. But sometimes we're gonna use it as positive. خلينا بس نقول يا شباب. So it's negative now. It's normally negative, okay? Times t squared, that will end up with, look at that, 25t minus half g t squared, where g is 9.8, of course. Yeah, let's just leave it as it is, as g. The second one, for the second ball, which falls down, d equal vit. I will use the same equation. This is general in both cases. But the distance now, the distance to be traveled for ball 2 to reach this point is 15 minus h. This one has traveled h, this one has traveled 15 minus h in the same time. That should be 15 minus h equal vit. Vi in this case is 0, so that will be 0, plus half a is g. In this case, as long as there is no term here, this term is 0. If this term is 0, يعني vi is 0, of course this term will be 0, you can put g as, it should be like that. It should be like that. Look at that. It should be half times negative g times t squared. This is right. But as long as there is no term here, we can just get rid of the negative here. This is the only case we can put it as positive. If there is no vi, we can just regret. We can just ignore the negative sign here. So 15 minus h equal half g t squared. We have an equation here. We have an equation there. Look at the two equations. We have something in common in between, which is this value. Look at that. This value is common here and there. Half g t squared equal 15 minus h. I will just remove this and put it 15 minus h instead. That's simply because, again, half g t squared equal 15 minus h. So I can just remove this value, put it as 15 minus h. So this equation now will be rewritten again here. It will be h equal 25t minus half gt squared equal 15 minus h, which tend to be 25t minus 15 plus h. This is h. This is going to move with that one, will be cancelled, and we will end up with 25t equal 15, from which t equal 15 over 25, that end up with 3 over 5, which is 0.6 second. A boat can travel with a maximum speed of 12 meters per second in still water. So that's, I think, should have a kind of comma here. Okay? So this means the maximum speed of the boat in the still water, the water that does not move in the river while there is no currents, يعني مفيش تيارات مية راكدة يعني, the maximum speed is 12 meters per second. Okay? Now it looks like this boat is gonna move inside the currents or in a river that has currents, في تيارات. Okay? It's moving now against, so in the opposite direction يعني. The current, تيار of the stream that flows with a velocity of 5 meters per second. So that's the relative. So this 5 meters per second relative to the bank, which means that the current, التيار الماء نفسه, is moving 5 meters per second, not relative to the boat. It's relative to the bank, الضفة. Okay? What is the velocity of the boat relative to the bank of the stream? So let us just sketch it. It looks weird, okay, the statement itself, but if you just make a kind of, sketch, it will be much easier. Here we have the boat, يعني. Yeah, it's not that good. And here we have the stream, okay, the river stream. The river stream itself is moving with a velocity of, let us say that it's in that direction, for example, v of the stream equal 5 meter per second, and v for the boat is what we are looking for. You might tell me that it's 12, 12 relative to the still water, if it is in still water. But it enters now in a moving stream, so it should have a different one. He's asking about how much would be that one. الماكسيمم بتاعتها يا شباب، الماكسيمم if the water is stand still, the maximum is 12. Of course, for one on the bank here, للضفة يا شباب, one is stand still here. How much would be the velocity of the boat relative to him? It's normally moving with 12, but now as long as we have 5, or the stream is moving, the river is moving in this opposite direction with 5, for me on the bank, I will see this boat is moving with 12 minus 5. So the velocity of the boat relative to the bank equal 12 minus 15. That will be 7 meter per second. Now let us solve this problem. We have a football is kicked straight up into the air from the ground. It hits the ground 5.2 seconds later. So it goes up and then it turns back to the ground, and it took 5.2 seconds. With what speed did it leave the kicker's foot? The question is about the initial speed of the ball when the kicker has kicked it up. And one important thing as well that helps us too much, because if the air resistance exists, طبعا the situation will be much different. Yeah. So that will make things much easier. Air resistance is 0. It means many things for us. Ouch, what does it mean, air resistance for us? First of all, A equal G. The acceleration will be the acceleration of gravity. This is the first thing. Whenever we hear that the air resistance equals 0, if we need to find the acceleration of the object, the acceleration will be G, 9.8. So let us try to sketch it. Again, sketching the problem make it easier. So here we have the ball that has been kicked up, and it moves up and then it returns back again to the ground. It took 5.2 seconds here. From here to there took 5.2 seconds. As long as there is no air resistance, this is the second thing that we're gonna conclude from the air resistance equals 0. Negligible يعني is 0. A equal G. This is the first thing. The second, as long as there is no air resistance, so what's happening? This curvature, this motion will be like a kind of, it will be having kind of symmetry. يعني the speed of the ball here will be equal to the speed of the ball there. The speed is here equal the speed there. And this time that has been taken to the whole journey, half of it will be here and half of it will be there. يعني up to that point, at the maximum point the ball will reach, it will take 5.2 divided by 2. We need, remember شباب, we need the initial speed or the speed of the ball here when the kicker just kicked it up. تقول لي والله if we can get the speed of the ball there, this equal that. But can we get the speed of the ball at this point? Yes, that's so simple. We will start from here. Just forget about this part. I will start from here, شباب. From this point. At that point, the initial speed of the ball is 0. And it will move down in time equal, this time will be equal to 5.2 over 2. It will take in this journey down, it will take half of the time. But we have the time, we have the initial speed, we have the acceleration, which is G in this case. So we can easily find the final velocity from the simple equation. V final equal v initial plus at equal v initial is 0 and the acceleration of gravity should be negative g يا شباب. But as I told you previously, when vi equals 0, so we can just put it as plus g. So here we have plus 9.8 times 5.2 over 2. When you solve this simple mathematics, it should be something around 25.48 meter per second. Another problem. So we have here a student stand at the edge of the cliff, exactly at the edge of this cliff, and throws a stone horizontally. So he threw it exactly horizontally with a speed of 18 meters per second. That should be Vx. Remember, because he said that it has been thrown horizontally. So Vy يا شباب now at the beginning Vy equals 0. At the beginning, the initial velocity in the y direction is 0. The cliff is 50 meters above the flat. Okay, this is the flat of the ground, yeah. It's 50 meters above the ground. So we have the height. Above a flat horizontal beach as shown. It's above this level here. How far from the base of the cliff does the ball hit the beach? So he's asking about how much is that distance, x naught. How much is it? Okay, so solving this problem would be so easy if we have the time. If we have the time, it will hit the ground. Of course, x naught will be equaling to the velocity in the x direction multiplied by the time, if we have it. يعني I should say that the solution of this equation, of this problem simply, that x naught equal Vx multiplied by the time it will take to hit the ground. But unfortunately, we don't have this time, at least directly, we don't have it directly in the problem. But this is the equation that we're gonna use to find x naught. We have to use this equation. Vx is 18 meters per second. The x, it's a constant. There is no resistance, should be constant. So we can use this equation, but we don't know the time. How to find the time? We have to find another equation which contains this time. So we have to solve the other equation to get t and then to substitute t in this equation to find x naught. This is one of the most common problems in this type يعني. So we will get the time شباب. Remember, this ball that has been thrown horizontally, it will take this shape, the projectile shape, it will hit the ground after time t. And we can say something else. If we leave this ball, instead of pushing it forward, if we leave it to drop downward directly, it will take the same time t, as we have discussed already in one of the lectures. This time here for the ball that falls down directly equals the time it will take this ball to move forward and downward at the same time to make a projectile motion. So if we can get this t, the time it takes this ball to fall down directly, we will solve the problem. How to get that, شباب? That's so easy. There is no resistance, remember. A equal G. And we have this height. We can use this equation, D equal VIT plus half a t squared. Where D would be in this case h. D is the distance in the y direction will be h. So I will just put it h. Equal Vi in the y direction. Vi in the y direction was 0. So that term will be 0. Half A tend to be G, an object that moves down without any resistance. A resistance should be the acceleration A equal G So that will be times 9.8 times t squared. Of course, we have h here, it's 50. So 50 equal half times 9.8 times t squared. So after solving for t squared, or for theta, of course, yeah, and after solving, you will find that t equal almost 3.2 seconds. Then substitute with this t in that equation. X naught equal Vx, which is 18, times 3.2, that is almost a kind of 57.5 meter.